recording is rolling. It is Thursday, August 24th. Okay, so yeah, I got a few things lined up on this agenda today, and then speaking of tomorrow, real fast. You guys know tomorrow there's a pep rally, so they're short classes today. Just shaved a few minutes off each class, and then pep rally at the end of the day. Okay, so we got that to look forward to. Also, okay, so I know the last few days we've been looking at a little bit at this trigonometry. Okay, actually, on one side, I was having you guys do this trigonometry lab, helping you guys fill out this table. And on the opposite side, there are these 10 triangles, and there's this model right triangle here, but these are all different angles and different types of vectors or whatever. Okay, and we did 3 of these in class. Okay, guys, this page, both sides. Now I'm treating this 2 separate assignments. If we finish this whole thing, then do you guys see this gray tray up here? You guys see this gray tray? Anything you turn to this gray tray, well, I'll pick it up and grade it there. If you need some extra time, then actually between today and tomorrow, I'm pacing things out a little bit slower than I have in the past. So if you got stuck on some of these and you need to ask each other or ask me, then today would actually be a pretty good opportunity for that. Okay. But can you guys turn this in by tomorrow? All right. So if you have any questions today, then good time to ask me, and then turn it in tomorrow. All right. And then main thing today, and actually this will take us today and also tomorrow. I'll give you guys time for this, and then we'll go over these graphs on the back on Monday. So today, tomorrow, Monday. It's going to be this car and incline lab. So it's Hot Wheels Day finally. Hot Wheels Day. Everybody does have one of these pages, right? Okay, it says car and incline lab. Oh, guys, go ahead and write your name right here. Write your name. Got car and incline lab. Okay. And this is a big important lab right here. I'm probably going to be referencing this lab throughout the year. I wouldn't be surprised if I was talking about this lab the day before the AP exam. Okay. So here's the premise: is you guys see those inclines back in the lab area? Okay, so there's some incline. I'll give you guys a Hot Wheels car. Now most of them have good wheels. I double checked this morning. This one kind of junky wheels, so I took them out of this one there. But okay. So you let this car go down, and I want to figure out what equation or equations. Here's kind of the question sorted. Right? What equation or equations could govern the motion of the car as it's rolling down the incline? Now, there could be lots of variables we could consider. I want you guys to brainstorm some variables. I'm going to ask you guys shortly. Okay? But some things are going to be locked in place. One thing is this angle. You guys see this angle right here? We're just going to lock that in place. So once you have an angle set, if it's like 5 degrees or 10 degrees, just go ahead and leave that the entire lab. Okay? In the future, in a few weeks from now, we'll consider what would happen if you change this angle, but not today yet. Okay? Because what else do you think would be maybe a potential variable that could govern motion of the car that we can't realistically change inside this room?
Would it be like friction on the surface of the track?
That's a good consideration. Do you guys see these wheels right here? Do you guys think this is basically a low friction system? So this is sort of supposed to model this. Guys, what if this was an air hockey table? You guys ever played air hockey? Basically, no friction or such tiny friction, I'll call it negligible, right? Do you guys think if you had an air hockey puck and it zoom down this, and you had this Hot Wheels car that's like zoom going down, they would basically go side by side. So we're going to say that represents either zero friction or negligible friction. Right? I'll tell you what, as a side thought, since you guys are AP here, this was a question I think a couple of years ago. They said, what if you had like a car with wheels and it did not exactly model like an air hockey puck going down with zero friction? Why could that be? And it was a little bit open-ended. But the main answer I think they were looking for, they would accept like 3 or 4 or 5 different things. But you guys see these wheels right here? Now, I'm really thinking way ahead in this class. I'm overcomplicating this for today. But do you guys think realistically it takes some effort to get these wheels turning, especially if they were really massive? There's something called rotational inertia. We probably won't even talk about that until January. But yeah, as a simplification, we're going to assume that basically this is a zero friction system. Okay, great. So that's a good consideration. Guys, what about this? What if you took this out into deep space, like the International Space Station? You got an incline. Would this even move at all in the International Space Station? No, you let it go and it just kind of floats around, doesn't it? Okay. So you need a what? Yeah, gravity field, like gravity. Okay. And do you think if you put this on the move, do you think it would roll down differently than on Earth? Yeah, but are we all kind of locked into a gravity field? We can't realistically change that in this room. Right. So that might be a variable that has something to do with this governing equation that we can't really test for in this class because we can't really change it as a variable. Right. So with that in mind, what could you change or what could you measure? What do you think? With one thing. What do you think? Ooh, speed of the car. Yeah. You guys see this little finish line down here. Okay. Can I set up the speed gate? You guys remember the speed gate right here? Okay. Now the car zoom go through it. You can see like how fast it's going. Maybe at a particular point, basically. Okay. Now how it works is there's a couple of sensors. So this car goes past this one, past this one. It says how far to go and how much time it divides it. So it gives you a speed. Right? We'll treat that as an instantaneous speed. Okay. You guys think as let's hypothesize a little bit. Okay. Suppose you let the car roll like 100 centimeters and you get a speed. Okay. What if you double the distance? By the way, that's another variable. You guys see is x distance. Okay. What if you double the distance? Would that be more speed? Going faster? How many of you guys think it's going faster if you let it roll further? Right. Does anybody think it'd be the same speed if you let it roll further? Right. Okay, so if I double the distance, is that going to be double the speed? Or more than double speed? Or increase speed, but not quite double? All right. What do you think? Okay. You could sort of hypothesize in your mind, because that might have something to do with something like this, right? Right? Or what about this? Could you guys time how much time? Oh, a little stopwatch right here. Time how much time it takes for the car to roll down? Right? What if you let it roll twice the time? Like let it roll for 1 second, and then I would have to change the distance for it to roll more time. Okay, so these are kind of related to each other. Okay? What if it rolled for double the time? Would that be double the speed? Or more than double, or increase but not quite double? Huh. You think about this, right? And speaking of distance and time, I guess those would have a relationship too. Because if you let the car roll for double the distance, let's say 100 centimeters, and then you back up and let it go 200 centimeters, that would be double the distance, wouldn't it? Right? Yeah. Would that be double the time, or more than double the time, or not quite double the time? Right? Right, because there would be an answer to that, right? And you guys see what I'm saying about like half and more than half and double and blah blah blah, right? So what we'll be able to get out of this is some kind of proportional answer, right? And if you went back and changed this angle, do you guys think the more vertical you make this angle, the closer it's going to model like exact gravity free fall, right? If this was 90 degrees, it would be perfect free fall, wouldn't it? Right. So this is somehow proportional to gravity in some way. In these equations, we'll be able to model something like dropping a ball off a cliff. Right? You know what? There's another variable that I might want you to test for that I have not mentioned yet. What else do you think you might also want to check? What would you say?
Height.
Okay. Right. I thought you said something different, but I'm glad you said that. You said height here, right here. Right. Tell you what, I'm glad you mentioned that, and here's why. Because let me go back to this angle. Guys, could you use a protractor to measure this angle? Measure how many degrees this is. Okay. And again, once you have that, then go ahead and lock that in place so that there it says angle equals blank degrees, you just control that, keep it as a control. Okay. Suppose it's like 7 degrees, you just keep that control. Okay. But there is an alternate way you can get the angle without using a protractor. Right? You might want to try this just to see if it works. Okay. Let me draw it this way. Okay. Now I'm calling this, you could call this distance D, you could call it X, you could call it L. Maybe I'll call it X right now, just to match my picture. Okay? So I call this side H, and I want to solve for this theta. Who remembers how can you solve for this theta based on this incline length and this height change? What do you think? Take a
Sine, right?
okay, something to do with sine?
It's
Arc sine. Yeah, you guys remember arc sine or inverse sine? Okay. So theta equals, and you know something to do with sine because I see an opposite leg and I see a hypotenuse. So something to do with sine. But if you want to extract the angle, that is an inverse sine, or you can say arc sine. Yeah. So you could do h over x. That should tell you the same thing. If your calculator's in degrees, then it should match exactly what the protractor's saying if you're using this correctly. Okay? You guys get that? Okay. Here's another detail I forgot to mention. There's another way to measure speed. So you could use a speed gate, but guys, if AP asks you this exact question, AP doesn't know what a speed gate is. So your grader would be confused and you wouldn't get the points. Okay. AP does know what a motion detector is. You guys see this right here? Okay. So this is if the car is headed either straight towards it or straight away from it. Now, you have to take this USB cable and hook it up to your laptop. Now, I'll leave this up to you. If you want to get your hands on this and try this out, you can. I always have trouble getting this to work, but if you can get it to work, it'll tell you displacement and velocity and also acceleration. So it tells you a lot of stuff. So if you want to try this out, you can. And then AP does know what a motion detector is. So AP would know something going straight away or straight towards it. Okay? Right. So up to you. There's a bunch of these back there. Right. So let's look at this table. Okay. So think what variables could you maybe want to keep track of or could you keep track of? Now, you guys see the organization of this? I got trial and unit. So if you guys go trial like 1, 2, 3, 4, 5, 6, or you can call it A, B, C, D, E, F. You can name whatever trials, right? And say, have this kind of divvied into three. Do you guys think that maybe one important step might be to do like take 3 trials and an average, something like that? Especially if you're keeping track of time, because there's a lot of error associated with keeping track. Like when you start stopwatch, that's a really common thing. And AP is going to be looking for that too. They want you to do 3 trials and take an average. They'll say multiple trials to reduce experimental error. Right? I have that written down. I'll show you guys that later. That's another point I want to make later. Right? Let's go across this across these columns in the top. Right? So what variables could you measure? And then this second row is for corresponding units. Okay? Here, I'll throw a 1 on the board. Could you measure how far the car rolls X? And you have a couple options. What unit do you think? Yeah, centimeters works. So I'll leave it up to you. If you want to do meters or centimeters, I'll leave that up to you. Okay. Okay. Again, just as long as you're consistent throughout, then I'm looking for proportional relationships at the end. By the time we get to these graphs on the back, we'll get some proportional relationships. Okay. What else could you measure? Time, and you can measure that in what unit? Seconds. Right. See, I'm embedding the unit in the in this top. Well, at the top of each column. So that when you write a number, suppose you write the number like 1.12, that number automatically has this unit embedded. So, that's 1.12 seconds. Okay, guys, in this class, numbers have units attached to them. You have to know what you're talking about. What else could you measure? Huh?
Speed.
Oh, yeah, speed. What character do you think I'm going to use to represent speed in this class? Yeah, V for velocity. Yeah, and the units could be either meters per second or centimeters per second. Right? So if you're comparing these two directly, you might want to do either both centimeters, both meters. Right? Okay. But I'll leave it up to you. Whether you want to do meters per second or centimeters per second. Okay? I'll leave it up to you. Okay? Again, if these match, that's meters and meters per second or centimeters and centimeters per second, it might make the equations easier in the end. Okay. What else did I say to measure? Keep track of? Did I say the mass of the car? Wait, I didn't talk about that yet. Whoops, I missed that one. Oops. Let me go back to where's my picture? Where's my picture? Oh, I had it set up here, didn't I? All right, here we go. Okay. You guys see I labeled this M for mass of the car? Right. Guys, what if I do this? Back on the lab table, I have boxes of these lab weights. Okay. What if you let a blank car go down? By the way, a car's approximately 33 grams, plus or minus a couple of grams. There is one digital scale back there. So if you can weigh your car, you can. If you can't get hold of the scale, then it's okay to call it 33 grams. That'll work perfectly well for this lab. What if I take this 100-gram lab mass and I tape it to the car? Could that possibly affect how the car goes down? Incline? Right. Let's do some hypothesizing for this one. How many guys think? And there are 3 possibilities. Wait, okay.
Is the tape weight negligible or mass?
Yeah, is the tape mass negligible? I would say so, yeah, because the tape would be much, much, much less than this, right? But if you want to be really exact about it, you could take the whole system, like the car and the lab mass and the tape, and you can put it on the scale and get exactly, you can know for sure, down to the how many point whatever grams. Okay. Here, let me throw 3 hypotheses at you guys, and you guys tell me which one you think is correct. Suppose I have a blank car going down, and it takes some time to go this distance, and then I go back and I increase the mass. Is that going to make it go down really fast? That's to say, very little time. Is it going to slow it down, make it take a long time to go down, or is it going to take the exact same time so that a blank car and a car with weight could travel side by side? How many guys think the car with the lab weight zips down really fast? Who thinks that one? Who thinks the lab weight attached to it is going to slow it down? Who thinks it slows it down? Okay. And who thinks that this would travel side by side, like the same speed, same distance, at the same time? Anybody think that? Right. Okay. Well, we could test for that too, couldn't we? Right. So you have to find out. So I'm going to put M for mass of the car. And what do you think is a reasonable unit today? Grams. Grams is good. Okay. Now, of course, you guys know the actual base SI unit for mass is not grams. It's actually what?
Kilogram.
Yeah, kilograms, which is of course this. But I think grams is more like a reasonable number to work with today, if you like. Okay. Now, I do have a couple of blank columns because depending on what exactly you're solving for, you might want to manipulate some of these variables that are already written here. Okay? And what do we, here, or kind of walk towards that. Do you guys see at least 4 different variables floating around? Hey guys, in a very well-designed experiment, ideally, you want to have how many independent and how many dependent variable?
1 and 1.
Yeah, 1 and 1. And I would leave the other 2 controlled, right? Okay. So I'm going to definitely control the angle. I'm controlling the gravity field. I'm going to control, well, 2 of these 4, and then change 1 and the other should automatically change, sort of. Right. Okay. Sort of. Now there's an exception to what I said, but here I'll get to that in a minute. Okay. So I need to split you guys up into different groups. It's kind of where I'm leading this. Right? I need to split you guys up into different groups. Now, do you guys see a playing card taped to that bar stool in front of you? You guys see it? You guys see a playing card? It should have a suit on it. It should have a suit. So I want to make sure that all these experiments are covered. Okay. So it should have a suit. If you have the clubs, who has the clubs? Who sees the clubs? If you have the clubs, what I want you guys to do is to change out the mass of the car and see how much time it takes to roll some set distance. Say that you could do 200 centimeters over and over and over. That you can send down a blank car, call it 33 grams. You could start taping on lab weights. Can you guys tape on lab weights? Hey guys, if you do that, make sure that the tape is not touching the wheel because that would slow it down. That would introduce friction you don't want. Make sure the tape is not dragging on the surface too, right? Okay. Can you guys do that? You guys can tape on all these different lab weights. Okay. Okay. And I had you guys hypothesize: does more mass slow it? Slow it down would make it go like this, right? Does more mass make it speed up, which make it go like this? Or would there be no relationship? If you go side to side, which make it look like a flat graph, right? Okay. How about if you have the spades? You guys see spades right here? I want you guys to figure out what's the relationship between distance and time. Now, if you do that, you can just use the blank car over and over, right? You don't have to change that. In fact, you shouldn't. That should be control. Okay. So maybe you should do this. If you have the spades, then let the car roll 50 centimeters, and how much time does that take? Maybe do 3 trials and take an average. Let it roll 100 centimeters, let it roll 150, let it roll 200. So see how you're changing the distance? You're saying how much time? Right? You guys see that? Right. Now, as a convention, one of your rules in physics is if time is ticking, you always put the time on the horizontal axis. That's why I have this oriented this way. Okay? Right. Guys, also, if you have spades, I want you to make another graph. You see this graph here? That's so there's x versus t, right, in meters versus time, or you can do centimeter or meter. Okay. There's also this. What is this? X versus what? What is that?
T squared.
T squared times squared. This is a manipulated variable. I know I'm giving you guys a lot of info dump right now, so I'll let this play out. And you guys will see by the end of Monday why I want you to also make this graph. In fact, that could be handy. If you have the spades, go ahead and write in one of these axes do times squared. And what do you think the unit is for times squared?
Second squared.
Second squared. Square seconds, right? So for example, if it took 3 seconds to roll down, wouldn't this be like 9 square seconds? 3 squared is 9. Okay? Okay. That's if you have the spades. Okay. And again, why you're doing that will make sense in a few days. Okay. Okay. If you have the diamonds, tell you what, the diamonds and the hearts are very, very similar. They're almost indistinguishable. If you have the diamonds, I want you guys to figure out what's the speed of the car as a function of some time. So you have the stopwatch and the speed gate. You guys have that? Okay. If you have the hearts, now this is almost identical, except instead of the stopwatch, I want you to just say how far is the car rolled, and also use the speed gate at the end of some distance. You guys get that? Right. Now you might be thinking, well, hold on a minute, aren't these sort of related? Because isn't it true if the car is rolling a further distance, it also takes more time, vice versa? Right. So you can't exactly weed these out. They are related to each other. But if you have the diamonds versus the hearts, just keep track of different variables. You guys have that? Okay. Also, if you have the hearts, there is one more thing I want you to do. You guys see this last graph right here? See where it says v squared versus x? You guys see that? Right? In fact, if you have the hearts, what do you guys do? Go ahead and make this one of your columns. Do v squared. And that could be in either meters squared per second squared or centimeters squared per second squared, depending on how you decide to measure it. You guys get that? Okay? Right. That's only if you have the hearts. Again, why will make more sense in a few days. Okay? Great. Any questions so far? Okay. So there's, I think, one more thing I want to tell you guys. Right. And the last thing is, you guys should have a quarter page in front of you that says AP style write-up. You guys see this? Okay. So this is one more thing in addition. So for AP, and this will be one of your free response questions, and they'll ask you something basic. So throw a question to you guys. And your question depends on which suit you have. For example, if you have the spades, it says, what is distance as a function of time, basically, right? Right. So that could be your question. Right. They'll want you to list measuring equipment. So again, for example, if you have the spades, when you have definitely a ruler and a stopwatch. Okay. Definitely mention the ruler and stopwatch if you have spades. Okay. Okay. Now, okay. Because those would be variables. procedure. Briefly describe lab setup. Now, guys, this does not have to be fancy. You can do this in one sentence. You can say, set up an incline and let the car roll down. And that's it. That's it. That's the entire setup. Set up an incline, let the car roll down. Okay. Which measuring tool to measure which variable? So if you have the spades, you'd say, well, I'm going to use the meter stick to measure how far the car rolls. I'm going to use the stopwatch to measure how much time does it take. That's all. Right? That's not hard, right? Also make sure you mention controls. So I'm controlling the mouse of the car, I'm controlling the angle, and so on. And you guys see this point right here at the bottom? It says multiple trials to reduce experimental uncertainty. That's always a point on the AP exam. So you say, well, I'm gonna let it roll 200 centimeters, but I'll do that 3 times, and I'll measure the time 3 times, and I'll take an average. Okay, you guys do that? Any questions up at this point? Okay. Analysis usually involves graphs. So basically, this side right here. Right? Oh yeah. What?
Mr. Griffin, do we need to put this on our AP lab notebook?
I'll leave it up to you, guys. If you bought your own composition notebook, yeah, you could write your write up in there. Alternatively, you can write this on a blank piece of paper. You guys have like copy paper, or something like that, right? Or take a piece of paper out. Okay. So guys, write up this write up, and on Monday, I'll go over a score and rubric with you guys, and you guys can get an idea of like how AP would score this. Okay, you guys have that. So we'll go over this on Monday. Okay. Okay. This analysis step right here. This analysis step is basically these graphs. So depending on which seat you have, you'll be able to guess either 1 or 2 graphs with your own data. And again, on Monday, we're going to bring the whole class together, and we'll make all the graphs, so everybody has all the graphs. Okay. But you individually and your teammates will be able to only create either 1 or 2 of these. Okay? And conclusion, because when you get to the conclusion, make sure your conclusion answers their question. Okay? You guys have that too? Okay. Okay. Any questions so far? Any questions? Okay. I know that was a lot of stuff, but I'll give you guys the rest of the class today and also tomorrow. Today and tomorrow. You can gather all your data, and also if there's any questions about the trig lab. Great. Yeah, let me here, I'll leave this up. Okay, so I will close down this recording and walk around and help you guys out.